If we place a closed conductor in an alternating magnetic field, then an induction current arises in this products. The reason for this is electromotive force of induction. Lenz's law states that the current induced in a circuit due to a change in a magnetic field is directed to oppose the change in flux and to exert a mechanical force which opposes the motion. Note that the formula on the right has a minus sign. In other words, an induced current will always oppose the motion or change which started the induced current in the first place, and this idea is found in the analysis of inductance. Okay, let's try to repeat the experiment with an aluminum ring and a magnet. I have an aluminum ring and a good neodymium magnet. The aluminum ring is a closed conductor. The movement of the magnet toward the center and from the center of the ring induces an EMF near the ring and resists the movement of the magnet. Moreover, the faster the magnet moves, the greater the confrontation. Well, let's now see how an alternating current of 50 Hz affects our ring conductor. I made an electromagnet with a core from a steel cylinder with a diameter of 25 mm and a coil with 1700 turns with a wire of 0.53 mm. On the right is a simple power regulator. The power of the magnet is adjustable from 15 to 300 watts. The EMF that occurs in the ring overcomes the gravity of the ring and pushes it up. But since the magnetic field decreases with distance from the coil, the EMF of the ring also decreases. Therefore, the ring hangs in the place where these two forces become equal. By changing the power regulator, I change the strength of an alternating electromagnetic field, and from this the height of equilibrium of these two forces changes. If you put this ring and then turn on the electromagnet even at medium power, the EMF simply spits the ring out of the rod. These are two identical duralumin rings. But on the right the ring is whole, on the left is a ring with a slit. Also among my old trash, I found a thick aluminum tube with a wall thickness of 9 mm. It weighs 160 grams. Of course, copper is a better conductor than aluminum, but copper also has more weight, so these tricks with aluminum are more efficient. This duralumin disc has a thickness of 3 mm and a diameter of 90 mm. After 30 seconds the disc becomes so hot that it is difficult to hold in your hand. This indicates a very large current that runs in the disc. But the maximum voltage in the ring is not more than 0.1 volts. A copper plate bent into a tube. 8 turns of copper wire. This is a small coil with a 1-watt lead. See also the operation of a 20-watt halogen lamp from a small coil. The coil has few turns, so the lamp shines less than half. In fact, as with the lead, this is a model and demonstration of the operation of the transformer with voltage reduction. I hope the video was interesting for you. Thanks for watching.